At the heart of China's Yangtze River stands the world's largest ship lift, a vertical elevator that raises.
The twin towers of the Three Gorges shiplift rise from the riverbed, concrete monoliths engineered to
From ground level, the structure's true scale becomes apparent. 110 meters of reinforced concrete designed to support.
Below the dam, cargo vessels queue, bulk carriers, container ships, and barges waiting to assist. Each vessel bears the marks of decades navigating these waters, weathered hulls that tell stories of countless voyages.
Engines maintain position against the current as captains calculate their approach to the chamber entrance.
The queue extends for hundreds of meters. Each transit through the lift takes approximately 40 minutes from entry to exit.
A 3,000-ton container ship breaks from the queue. The lift can accommodate vessels up to 3,000 tons displacement.
On the bridge, the pilot reviews positioning charts. Precision matters. The chamber allows less than 1 meter of clearance on each side.
The entrance gates span 34 meters wide and stand 38.5 meters tall. Massive steel barriers designed.
Each gate weighs over 850 tons. Counterbalanced and powered by hydraulic systems, the ship reduces speed to a crawl. Harbor patrol boats monitor the approach, ensuring safe alignment with the chamber.
Deck crews prepare mooring lines, thick ropes that will secure the vessel during its vertical journey.
Hydraulic systems engage. The gates begin their opening sequence, parting to reveal the chamber beyond. Hydraulic pistons extend with calculated force, each movement monitored by sensors measuring pressure and position.
As the gates widen, daylight floods the chamber. The opening takes approximately 3 minutes to complete.
Below the waterline, the ship's hull displaces thousands of cubic meters, a submerged mass about to defy gravity. The vessel glides into the chamber, filling the space with less than a meter to spare on either side.
Precision navigation is critical. The hull passes within centimeters of the concrete walls. Any miscalculation could damage vessel or structure.
Once positioned, deck crews throw mooring lines to workers on the chamber platforms, a choreographed exchange repeated with each transit.
Mooring lines are secured to concrete bollards, rated to withstand the dynamic forces of ascent. Each line is tensioned and tested. The ship must remain stable as it rises. Any shifting could compromise the ascent. With the vessel secured, the entrance gates begin to close. The ship is now sealed inside, isolated from the lower river. Rubber seals compress as the gates meet, creating a watertight barrier capable of holding back the river's immense hydraulic pressure. The chamber holds 15,500 cubic meters of water.
In the enclosed space, every sound echoes. Water droplets fall from the ceiling, marking time before the ascent begins. In the enclosed space, every sound echoes. Water droplets fall from the ceiling, marking time before the ascent begins.
The lift mechanism relies on 256 steel cables, each 68 millimeters in diameter, working in perfect synchronization.
Each cable is rated to support 370 kilonewtons, together capable of lifting 18,000 tons.
The cables descend through guide systems, monitored by redundant sensors. Any cable failure triggers automatic braking. In the control room, 3 operators monitor every parameter. 70 cameras provide complete visual coverage of the system. With all systems confirmed, the operator initiates the ascent sequence. A green light confirms activation. The chamber will now rise at precisely 0.25 meters per second.
A subtle vibration ripples through the structure. For a moment, nothing seems to happen. Then the ascent begins. The mooring lines tighten as vertical force transfers through the system. Ship, water, and chamber rising as a single unit.
The combined weight exceeds 15,500 tons, yet movement is so smooth the water remains virtually undisturbed.
Reference markers on the tower walls track progress. 10 meters, 15, 20, 25.
From the deck, crew members watch the concrete walls slide past. What was eye level is now far below. The water surface remains virtually motionless, proof of the lift's precision engineering and gradual acceleration.
The chamber rises between two worlds, the lower Yangtze, 66 meters below normal levels, and the reservoir 113 meters above.
From below, the chamber's undercarriage is visible, a complex framework of steel and concrete designed to distribute loads evenly. The ascent continues without pause, a vertical journey that would take a climber over an hour, condensed into minutes of smooth mechanical motion.
On the bridge, the captain watches the lower river shrink below. Vessels that seemed massive now appear as toys on the water. The steel cables vibrate under load, each carrying its calculated share of the total weight, monitored continuously for any deviation. Inside the towers, concrete counterweights descend as the chamber rises, a perfectly balanced system requiring minimal external power. Inside the towers, concrete counterweights descend as the chamber rises, a perfectly balanced system requiring minimal external power. At the midpoint, the chamber hangs suspended, halfway between the river it left and the reservoir it seeks.
For the crew, this journey has become routine, yet the view never ceases to command respect for the engineering involved.
Time passes differently in vertical transit.
Looking down, the original entry point is now over 80 meters below, a dizzying perspective that reveals the lift's true scale. Guide rails maintain perfect vertical alignment. Tolerance is measured in millimeters across the entire 113-meter journey.
Emergency brake systems stand ready, spring-loaded mechanisms that can stop the chamber instantly if sensors detect any cable failure.
Over 500 sensors monitor the ascent, position, velocity, cable tension, structural stress.
Maintenance platforms line the tower exterior, access points for the continuous inspection regime that keeps the system operational. In the control room, operators track every meter.
67, 71, 74.
The chamber approaches the level of the dam itself, equivalent to a 35-story building, one of the tallest ship lifts ever constructed.
Above, the upper gates come into view, identical twins to those at the bottom, holding back billions of liters of reservoir water.
Passing 100 meters, the final phase of ascent begins. Deceleration is gradual to avoid disturbing the water.
105 meters, 108, 111. At 113 meters, the chamber reaches its destination.
Hydraulic locks engage with precision, steel pins sliding into receptacles, securing the chamber to the tower structure.
The upper gates stand closed. Beyond them, the Three Gorge Reservoir waits at 179 meters above sea level.
Equalization begins. Water flows through ports in the gates, initially as small streams, gradually increasing as pressure balances.
The flow intensifies into rushing torrents. Over 800 cubic meters of water must enter the chamber to match reservoir levels.
As water enters, the ship rises on buoyancy. Mooring lines slack, then retension as the vessel adjusts to the new level.
The water climbs past chamber markings 3.0 meters, 3.2, 3.5. Equalization takes approximately 5 minutes. With pressure equalized, the upper gates begin to open. The same hydraulic power that sealed the chamber now grants passage.
Rubber seals release their grip. Initial turbulence quickly subsides as water levels achieve perfect equilibrium.
The gates open fully, revealing the transformation complete. The ship now floats at reservoir level. 100
Sunlight floods the chamber. The vessel that entered in morning shadow now basks in midday brightness at the summit. Deck crews release mooring lines, each rope carefully coiled and stowed, ready for the next vessel's journey.
The lines slide through deck cleats, fibers worn smooth by countless transits, each strand bearing witness to years of service.
On the bridge, the captain signals the engine room. Throttles advance, propellers beginning to turn.
Engines engage, churning the water at the stern. After 40 minutes of vertical transit, forward motion resumes. The ship exits the chamber into the Three Gorge Reservoir, a body of water that exists only because the Yangtze was dammed.
Behind the departing vessel, the empty chamber awaits its next cargo, a cycle that repeats dozens of times each day.
Between transits, maintenance never stops. Cable drums require constant lubrication to prevent fatigue and corrosion. Technicians inspect every meter of cable using ultrasonic equipment that can detect internal flaws invisible to the eye.
Tension monitors record every variation in cable load. This data predicts maintenance needs before failures can occur. 256 cables work as one, a testament to precision engineering, where failure of any single strand cannot compromise the system.
Deep within the towers, concrete counterweights balance the system. 11,000-ton mass that...
Control room operators access real-time diagnostics. Every sensor, every safety system, displayed and logged.
On monitors, cable tension graphs display perfect balance. Any deviation triggers alarms before it becomes critical. The empty chamber begins its descent, faster without cargo, returning to receive the next vessel waiting below.
The chamber falls past markers in reverse, 100 meters, 85, 70, counterweights rising as the chamber drops.
Lowland. As sunset colors the Yangtze, floodlights illuminate the lift structure. Operations continue 20
Against the darkening sky, a new vessel enters for night transit, commerce that never sleeps on one of the world's busiest waterways.
Under portable spotlights, night crews secure mooring lines with the same precision as their daytime counterparts. In darkness, the ascending chamber becomes a constellation rising, navigation lights marking its progress toward the stars above. Time-lapse reveals the night ascent as streaks of amber light climbing through darkness. 7 minutes compressed into seconds.
The lift accommodates diverse cargo, and this bulk carrier rides low under tons of coal, bound for power plants upriver.
Container ships carry manufactured goods, international trade flowing through China's interior, enabled by this vertical passage.
Passenger cruise ships carry tourists experiencing the lift as attraction. Engineering transformed into spectacle.
Even weathered river barges with decades of service navigate the lift, ancient and modern technology meeting in daily routine.
Maintenance crews inspect cables centimeter by centimeter, tedious work that prevents catastrophic failure.
Workers rappel down gate surfaces checking seals and mechanisms. Maintenance that requires both courage and precision.
During annual maintenance, the chamber is drained completely. Workers descend into the empty void to inspect every surface.
Sensors require constant calibration, precision instruments, ensuring the system's safety margins remain within specification.
Control room shifts change every 8 hours, operators briefing their replacements on current status and pending transits.
The system can manage multiple transits, one ship ascending while another prepares to enter, orchestrated from this single control point. Emergency protocols line the control room walls, procedures drilled regularly, though rarely needed in actual operation. Emergency protocols line the control room walls, procedures drilled regularly, though rarely needed in actual operation. Human oversight remains essential. Operators whose vigilance ensures automation functions as designed.
The reservoir extends over 600 kilometers, an artificial lake created by damming the Yangtze, fundamentally altering the region's geography.
The ship passes over flooded valleys where villages once stood. Transformation that displaced over 1 million people.
New cities have emerged along the reservoir shore, development enabled by year-round deep water navigation.
The ship continues its journey deeper into China's interior, cargo that will travel hundreds of kilometers beyond this point.
The ship passes beneath bridges that exist only because the river rose 113 meters. Before the lift, cargo required laborious transfer between vessels at different elevations, a process taking days, now accomplished in minutes.
The ship lift is one component of the Three Gorges complex: dam, hydroelectric plant, ship locked, and lift working as integrated system.
The dam holds back the Yangtze, 2.3 kilometers of concrete, retaining one of the world's largest reservoirs. Hydroelectric turbines generate 22,500 megawatts, power for over 60 million people, extracted from the river's downward force.
The 5-stage ship lock handles vessels too large for the lift, a parallel system using stair-step chambers to overcome the elevation.
For residents nearby, Ships rising into the sky have become daily scenery. Monumental engineering reduced to background.
Children grow up with the lift as landscape. For the next generation, this engineering marvel is simply home.
Thousands of jobs depend on the lift. Port workers, ship crews, maintenance teams, whose livelihoods flow through this vertical passage. The chamber returns to the bottom, gates opening to the next vessel, a cycle that repeats over 10,000 times each year.
Another ship enters. Another crew secures lines. Another ascent begins, routine transformed into rhythm.
Hydraulic systems engage once more, a process that has become as reliable as it is remarkable. Experience the ascent from water level, 0.25 meters per second, steady and inexorable. Concrete textures, steel cables, mechanical systems, intimate details revealed during vertical transit.
Past the midpoint, the view expands, mountains emerging from haze, perspective transformed by elevation.
At the summit, the reservoir reveals itself, a body of water stretching to the horizon, created by human determination.
Water where mountains stood, ships where none could travel. Geography reimagined through engineering will.
The ship continues into China's interior, its vertical journey complete, its horizontal voyage just beginning.
The Three Gorges ship lift, where vessels defy gravity, where engineering enables commerce, where the impossible becomes routine.